Welcome everyone. I'm so glad to be here to talk to you something that we are currently working on. So our topic here today is unlocking the real-time insight to unify the streaming and the Lakehouse analytics with the Apache Doris. So yes, the Apache Doris, have you anyone heard of Apache Doris? Can you hands up? Oh yeah, it's more than I expected, yes. Okay, so my name is Mingyu, and I am the Apache Doris PMC chair and also the co-founder and the VP of engineering at the VeloDB. So VeloDB is the commercial company behind the Apache Doris. And this is Kevin Shen, that is our senior product manager. Okay, so today's agenda is, we mainly focus on the real-time data analytics. So we want to talk about, why do we actually need the real-time analytics and what problem are we facing? And we also we will also try to discuss the challenges that a real-time analytics is still facing and how we build how we use the OLAP database like Doris to work effectively with the streaming data and the data lake data to build a effective and future-proof a streaming lakehouse or the real-time lakehouse. Okay, so now I will give the mic to my to Kevin, and he's a good speaker, and I am the technical guy. So if you guys have any technical questions during or after the talk, welcome to ask, and I will happy to answer. Okay.
Thank you, Mingyu. Hopefully today's going to be engaging, and we'll have a lot of questions afterwards. But really, I think, this is a pretty obvious question. We're at a streaming conference. We're going to talk about real-time use cases, right? Like low latency read, write, how to really get that fresh data that you need fast, right? A little bit of recap. I think you saw some of this earlier today during the keynote, right? Like, what does that low latency workload look like, right? Well, in a lot of cases, ad targeting. That's immediately right there. Like, you really need to get that most recent information and combine it against a lot of historic information. And that also extends into gaming, other things. But as technology evolves, there are more and more use cases that's going to really make or break based on how recent you can get that data. AI, nobody wants to sit there for a minute waiting for an agent to come back to you. Nobody wants to stand in the rain, getting rain on waiting for an Uber ride. These are some of the new challenges that are coming about. And then also, some of the things that you don't see often all the time with operations and observability, right? You need to have incident data as fast as you can so that you can get ahead of things before it even reaches the customer. So data freshness, latency, concurrency are very important. And we're going to talk about how to bring those capabilities to the streaming data, as well as what happens to that data afterwards or during streaming where it's combined with other data sources. Because looking at the data in a silo is not very interesting. It gets more interesting when you combine it with other things. So a brief level set before we dive into some of the challenges. So when we look at the components, right, these are non-branded components. Like, what do you really need to be able to have streaming data landing in Lakehouse and performing real-time analytics every step of the way, from looking at the streams to combining it with Lakehouse data, and then to actually look at everything together with other data that you have afterwards. So first, we're starting off with the streaming platform. Ursa is something that we're going to talk about, how it can effectively land that data in an interoperable space for everybody to pick up. And that happens to be data lake storage. In a lot of cases, this is realized through a lake house with additional metadata layers and governance and organizations on top. And then, of course, you really need that performant analytic engine to be able to query all of that data, bringing it all together. So really, we see that these three pieces is how we're going to create a streaming lakehouse and offer all of these real-time capabilities. Now, let's dive a layer deeper. Like, what problem exactly are we solving? And you're going to see some similarities. So when it comes to performing real-time analytics on streaming data, there are really two major challenges, right? How fast can we handle that data landing? Like, how fast can we write to that data? And I think through Pulsar, Ursa that we heard about today, this is pretty clear. And then also, how do we actually get to that data with low latency and high concurrency? And if we look at the challenges for reading that set of streaming data and looking at processing data in a lakehouse, you see similar things, right? For data management, it is always a trade-off whether or not you're going to be able to get fast reads or fast writes. And commonly we know this as, with Lakehouse tables, merge on read, which you merge all the files reading that, some latencies, but it's really fast to write these lower partitions, or copy on write, where you handle the taxes of performances on read early on, but your write's going to be slow. No matter which case, you're incurring latency. And that's that latency that we're talking about, like how do we bring that down? And the same sets of latency problems that we see in Lakehouses is also in streaming. But there's a couple of other things, right? For example, I/O. Sometimes you just can't beat physics, and there's only so much you can do, so you really have to minimize the amount of network travels to really be able to handle some of these things. Also, data consistency. And it's also important because you always want to be able to trust that data. And when you have these frequent updates, when you have multiple sources that are pushing data, you need to make sure that everybody's still looking at the same copy, right? That's the whole point of a lakehouse, is to bring that interoperabilities to multiple engines, to multiple use cases. So data consistency is also very important. And I'm going to summarize how all of these challenges forms a set of key requirements that we're going to have to fulfill. And VeloDB and Doris is that technology that's going to fulfill that. But before we get there, let's talk about some of these other pieces. So now we talk about some of the pieces in terms of bringing the data in, landing it in a place that's interoperable. We heard about this earlier today during the keynote. Then there's also Apache Iceberg, again, providing that additional layers of interoperability through standardized table formats, as well as making sure that there's quality of life added to it as well, so that you're actually able to use the same format and the same structure for different use cases. And then finally, there's Apache Doris, which we're going to spend some time really diving deep into, and that brings all of this together by bringing the ability to read all of these data formats from these data sources with low latency, high concurrency. And again, we heard about Ursa landing data in data lakes directly. That's great, but there's, again, different tiers of SLAs. Sometimes you may have SLAs that are super strict, where storage and compute decoupling is not enough. And there actually is a capability for that data to land with Apache Doris owned directly. In that case, we can still use the Iceberg format as that interoperability layer, but offer different tiers of SLAs. And we're going to talk about that in more detail later on. So a couple of brief introductions before we dive into the meat of this. Not going to talk too much about this, but hopefully everybody knows Iceberg. It's the predominant open table formats that brings a lot of modern capabilities, such as time travels, versioning, schema evolution, and it depends on which catalog you're using and who's managing it. You can also get additional statistics and performances. And we are proud that we are able to support Iceberg, and we're definitely working on with all the managed catalogs, as well as offering our own special secret on top of that to get some of the performance gains. And let's talk about Doris a little bit quickly as well. So Doris is a real-time hybrid analytics engine that is built for not only your structured searches, but also for hybrid searches. So the whole point here is really to bring that real-time analytics to your environment wherever your data lives, because your data could be anywhere and your real-time needs could be anywhere. It's a massive parallel process engine, so it could be horizontally scaled out for workloads of a variety of sizes, from gigabytes to terabytes. And it's able to be configured in a real-time operational mode, which we own that storage. It's coupled so that you can get that performance, right? You can get that additional metadata mapping to accelerate both write and read. But also, we're here to talk about Lakehouse, right? So it also has a storage decouple mode, which means that whatever that data is, it's shared everything, right? As long as you have that data managed by anybody else in any out of the catalog or formats that we support, we can query that data like any other Lakehouse engine. And we also have different performance acceleration built on top, again, to minimize that latency no matter where you're trying to access that data. And finally, something really cool that we've been working on for a couple of years is the ability to do hybrid searches. Because as I said earlier, one of the biggest challenges is with the evolving AI need, right? You need to be able to give answers back to the prompt, to the users in a timely manner. And you have to do that in a situation where constant updates and constant reads are happening, not just with structured SQL, but also with documents and contexts. And there, the hybrid searchability, again, bringing that real-time capabilities to those use cases as well. So I talked a lot about different technologies, the problems that we're solving. So what does it mean when all of these things get put together? So something looks like this, right? So the bottom hopefully is very familiar in terms of what Ursa brings into that cost-efficient ability to write that data into that lakehouse. It lands in Iceberg native, it can be used immediately, and it also can be landed in a Doris managed storage tier for additional SLAs. Once that data is in Iceberg format, we get that interoperability, and that's where Doris can actually query that table directly, as well as combining it with other data. That could be from Pulsar, if you need that extra performance that you're willing to pay. It could also be from different sources that are federatable. For example, you may have other databases or analytical stores that you may want to combine against that lakehouse data. Again, really making sure that you're bringing that real-time capabilities to all of that data. So I said earlier that I'm going to spend a little bit more time diving into the requirement sets that we now have seen some of the challenges, because we understand that, with anything, there's trade-offs. So the first thing is to make sure that we can actually perform real times in a streaming lakehouse. We need low ingestion latencies. So very critical, right? We also need data consistency to make sure that data is written in a way that we can trust and query, and that we don't have to worry about data qualities, completeness, etc. And also have to, of course, be able to support that fast write, fast update, fast upsert, etc. And it also has to have performances, because yes, you can bring that data in quickly. A lot of people can do that. But ultimately, if you're waiting for files to be merged and for things to be compacted so that you can actually access the analytics, then it's no longer real time either. And because we're talking about a lakehouse, it has to be highly scalable, highly flexible, highly interoperable. And ultimately, we're looking at adopting an interoperable solution because we want things to be simple. We don't want to manage 5 different data warehouses, databases, solutions with different skills, interoperability issues, and so forth. We really want to be able to bring a few number of technologies that are highly flexible and highly extensible to the stack, so that you can actually have a simplified operating model, easier to maintain things as well. So let's go through the first thing, right? Ingestion and data consistency. So one of the key things that we capabilities that we use to really make sure that we have that ingestion performance is group commits. If you have a lot of different IoT devices that are all trying to submit updates, we actually look at these and group them so that they're not all hitting your I/O at the same time. They're not all trying to update at the same time. It avoids some collisionings, and it also makes it much more efficient from that standpoint. The second thing is transactions atomically. We need to make sure that things are ACID compliant. And one of the things with Iceberg that's really cool is that it provides ACID, but at a single table. Well, that's problematic because sometimes you're updating multiple tables at the same time. You need to make sure that relationships are there. And that's where Doris comes in, right? We're not only guaranteeing you ACID at a single table level, but we also guarantee ACID for multi-tables. So if you're actually doing a lot of updates with multiple tables, we can ensure that there's consistency there as well. And then finally, of course, making sure that, again, with consistency, to make sure that you only have updates that happen once, right? So on each side, we make sure that from a Doris side, there's at least once. So we expect that at least one update comes in. And then from the source side, we need to make sure that there's at most once, right? Together, the two forms that there's exactly once to make sure that we know that there's only that one particular commit to make sure that everything remains consistent. The second thing we're going to talk about is updates. So I talked about a little bit about the techniques in terms of how to actually make sure that you get the best of both worlds, right? How do you get that fast write and fast read on an open table format at the same time? It's really tricky because, you either pay the tax up front or you pay the tax later. But what if you can pay the tax in between, so to speak? So in this case, what we're actually doing with Doris is that as we're writing this data in, yes, we're writing the micropartitions because we need to be able to write things quickly. So we're still writing micropartitions. But on top of that, we actually have an additional layer, a bitmap, that we, because we own the storage, we can kind of implement this so that it essentially acts as indexes on where the updates are happening. And when you're reading all of this data, instead of merging the actual files themselves, you can actually merge the bitmaps. It's a much, much cheaper task than trying to merge the files. So you can actually get that read performance because now you have that index, you can actually skip a lot of the smaller files and find the right ones that you need. Therefore, you're able to get kind of the best of both worlds. And we're calling this sort of called merge on write, right? It's a new term, basically trying to get the best of copy on write as well as merge on read for both write and read performances. And on the graph on the right, you can see that through this method, we can still achieve very high read performances, query performances, even after providing these small partition updates. And the blue bar is what Velo and Doris are able to offer, and the green bar is industry benchmark for standards. Of course, vendor agnostic on this page. And just to kind of put things into perspective a little bit, so here is the out-of-the-box performances of our queries against some of the common ones against about a 500 gigabyte data set. As you can see, Apache Doris performs quite well, in fact, comparable to ClickHouse tuned. Again, this is purely out of the box, not tuned or customized in any way. So you can see that, yes, out of the box, we're actually quite performant against some of the leading providers of these analytic solutions. So getting to a little bit deeper, right? So, kind of summarizing, what are some of the characteristics and performance optimizations that we have done, right? And this is on both read and write. So again, on the read side, on the reading the data side, we've vectorized our readers. So because we're MPP, all the worker nodes are C++ engines, so they're able to offer that fast read. Again, we do a lot to minimize I/O, so merge I/Os, lazy materialize, so we're basically only materializing the minimum amount of data required, again, to minimize that network travel. We also do runtime partition pruning. Basically, instead of trying to prune the partitions up front, which may be heavy, we do it as we're running the queries. And then we prefetch. We also provide a number of different data caches. And of course, for anything that has to do with federation, reading multiple catalog, multiple data sources, we also have predicate pushdowns when you're accessing those other data sources as well. And lastly, getting to scaling and operational efficiency, here's a view for putting everything together. So how do you actually put Apache Doris inside an open data lakehouse and all the integration it offers? So as you can see, this is surrounded by a rich set of ecosystems. We have streaming on the left, so there's Kafka, Pulsar, and of course, Ursa. And then we are, again, multiple catalog. We don't really care how you manage your data. You can use Unity, you can use Polaris, you can use Gravitino, you can use even high meta stores. A lot of people still use high meta stores as a metadata catalog, and we, of course, support that as well. And of course, I talked about different tierings of things, right? So on the very bottom, it's storage. It could be HDFS, it could be S3, your general data lake storage. And then we support your columnar formats. We're a columnar engine, so Parquet files, ORC. And then, of course, there's that metadata layer on top that we talked about it, with Iceberg being the predominant interoperable metadata standard. Of course, we support other ones as well because we know that there's many Delta users, as well as Hudi and a new one called Apache Pymon that actually came out to handle some of the similar challenges as well. So more of those are growing, and we're happy to be able to provide that interoperability across all. And then finally, getting into that color diagram, that's where the heart of Doris lays. And that really kind of is what I talked about today in terms of that data cache, in terms of that different set of configured engines that you can use for different purposes, whether that's a database configuration with owned storage, data lakehouse configuration, or even a vector store capability where you can actually use it as a vector DB. And of course, a number of performance enhancements such as materialized views, cost-based optimizers, a number of different performance techniques that we use to get to that fast querying. And of course, a number of different integrations and connectors with upstream services as well. Happy to talk a bit more about this. If you guys have any questions or specific integration questions that you wanted to bring up, we can always discuss whether or not we can fit into your architecture. Again, it's really about meeting you where you are. So finally, just kind of putting some of these things together, right? So I talked about some of the additional capabilities. One of the things that really stands apart is that materialized view and caching with these multiple sets. And you can see the tiered performances and SLAs that we can offer depends on how much you want Doris to manage that data versus being a shared everything model. So you can see that, just by using kind of your open source query engines for lakehouses like Trino or Presto, you get about, relatively good performance. This is Java-based, so there's certain limitation to it. But the moment you apply Doris to this, we can achieve about a 3-time speed gain against these open source, general purpose analytic engines. But if you get Doris to own that data, apply that additional layers of indexing and metadata on top, we can offer you even further improvements. Really about what's your SLA and how much interoperability that you would need. I'm gonna skip a little bit about this, just kind of refreshing, putting everything together. This is what that streaming lakehouse will look like with that shared layer of metadata and table formats, as well as the interoperabilities between Apache Doris and the streaming services that lands that data. And lastly, I want to spend some time talking about community and support because we would like a lot more people to use Apache Doris and come talk to us, right? So Apache Doris is a really cool project born out of needs from the largest search engines in the world, Baidu. Right now we have 14,000 stars on GitHub with over 700 contributors and 5,000 plus users. It is heavily used in the Asia Pacific region, and we're actually seeing an uptick in North America as well as some of these real-time problems land. And of course, we're participating in a rich ecosystem. So definitely check it out. Add a star and let us know. And also, to make sure that you can get started with Doris as fast as possible, as VeloDB, we provide a number of different services to help you get started. So if you want to host your own, absolutely, we offer that in terms of giving you the software and providing you support, mostly around security, governance, hardening. We have a lot of different certifications. So if you're in a regulated industry, it's very easy to kind of get a start from there. But if you don't want to manage your infrastructures and you don't want to deal with all of that pain, we actually have a fully managed SaaS service as well on all 3 hyperscalers. So no matter which infrastructure you like to run yourself on or what committed spend you have, it's very easy to get started. And we actually have a 2-week free trial right now for you to test out whatever you need on those use cases. And I'm very excited to announce that recently we also added support for AWS Graviton. So even for adding efficiencies to your analytic infrastructures, this is a lot more efficient, a lot more cost effective from that standpoint as well. And right now, I think I'm doing well on time, just about 5 minutes remaining. So happy to take any questions that folks might have.
So the app stores, as the message goes in, does it purely in memory, or does it do async?
Do you want to take that one?
Sorry, what it means, the data storage?
Yeah.
Within the persistent on disk.
In the persistent on disk.
Cache layer, like the page cache or some other kind of cache.
Is there a little bit of delay, or is it like as a row comes in, it's like as once row is committed is
Actually, after it's committed, it's async.
It's async. Okay, so it's pretty tight guarantee.
Yes.
Okay. Gotcha. Cool. That's all. Thank you so much.
All right, thanks everyone for coming. And we have a booth, so any more questions, please come by.